Step into the Coliseum, everyone. Welcome to The Explainer. Today, we are diving deep into the absolute battleground that is Cambridge Physics Syllabus 0625, Vector Fundamentals. And listen, I need to be completely straight with you right out of the gate. Mastering this isn't just some annoying box to check off your revision list. It is literally your absolute gateway to surviving and thriving in the forces and motion chapters. In the Cambridge exams, only the prepared survive. Now, to show you what I mean, I want you to imagine two classic students walking into this arena. Let's call them Alex and Sam. We see these two archetypes every single year. Alex is a hard worker, right? But Alex overloads every single answer with raw physics facts. Total brain dump. No analysis, no structure, just a wall of text hoping something sticks. And then there's Sam. Sam rushes, Sam looks at the clock, panics, and completely misses the specific command word requirements of the question. If a question says explain, Sam just states. When we look at their past papers side by side, it is just a sea of red pen marks. Marks lost not because they didn't know the physics, but because they didn't know the strategy. We are going to change that for you today. We are going to build your strategy from the ground up, starting with the core concepts that catch both Alex and Sam off guard every single time. So, let's hit our first real challenge. What physical prediction completely fails if you only know the amount, but entirely ignore the direction? Think about it. Let's use a massive real-world example. A high-speed car crash. If I sit here and tell you that a vehicle experiences a monumental force of, say, 50,000 newtons, which, by the way, is roughly equivalent to dropping an entire adult elephant onto something, can you honestly predict where that car is going to go? No way. Absolutely not. If that elephant-sized force pushes from behind, the car accelerates violently forward. If it pushes straight down from above, the suspension just compresses and the tires blow out. If it hits from the side, the car spins. This right here proves that vectors are practically necessary. They aren't just decorative textbook ideas. Without direction, our ability to predict cause and effect in the physical world completely collapses. We tackle this concept first because you have to literally feel why it's necessary before you start memorizing the formal language. Alex would just write, vectors have magnitude and direction, and stop there. Sam wouldn't even mention direction. But top-tier students understand the why. They know that physics is about predicting reality, and reality requires a heading. Okay, so how do we actually structure this understanding to get marks? Before we continue, subscribe to our YouTube channel, Ace the Exams, at @acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. All right, let's break down the ultimate strategy. When dealing with vectors, or frankly, any major scientific pattern in the 0625, 0651, or even the 9702 syllabuses, you need a structured sequence to guide your reasoning. You can't just wing it. Examiners are grading based on specific assessment objectives, so we use a four-step chain. Step 1, identify the quantity or phenomenon. Ask yourself, am I looking at a scalar speed or a vector velocity? Step 2, state the relationship involved. How does Newton's second law apply here? Step 3, explain the underlying physics. What is the actual physical mechanism causing the change? And finally, step 4, connect it to an observation or device. Now, this directly maps onto a framework top students use called PEL, Point, Evidence, Explanation, Link. Your point is identifying the quantity. Your evidence is stating the formula or relationship. Your explanation is the underlying physics, and your link is connecting it back to the specific device in the question. By guiding your reasoning through this exact chain, you transition from someone who just knows trivia, like our friend Alex, to a strategic gladiator who can conquer any structured IGCSE question. Now let's dive into the actual translation process, because this is where the red pen marks start turning into green check marks. The difference between a good student and an elite student is all about communication. It's incredibly tempting to look at an exam diagram of a box on a ramp and write down, the block gets pushed harder down the slope. That's everyday language. That's how you talk to your friends. But an examiner? An examiner needs precision. You must begin with that concrete, everyday example in your head, sure, but you only write down the symbolic relationship or the specific physics vocabulary when you put pen to paper. You don't say push. You specify the resultant force vector. You don't say it's speeding up. You analyze the acceleration vector. We're talking about precision. Think about it like a workshop. If I give you 60 seconds to rewrite the phrase, the car slows down because of brakes, a top student is going to transform that into a negative resultant force vector is applied opposite to the direction of motion, causing deceleration. Boom, full marks. This structured, vocabulary-rich approach makes you far less dependent on vaguely memorized textbook wording and much more capable of reasoning your way through completely unfamiliar, high-stakes exam questions. Now, what's really fascinating about vectors is how they map directly onto the visual data you'll be handed in the exam. I want to do a quick data scan challenge right now. Imagine a complex velocity time graph sitting right in front of you. Whenever a topic involves graphs, fields, or forces, examiners are hunting for one specific thing: cause and effect. They absolutely do not want isolated facts. Look at the features. If you calculate a graph's slope, you aren't just doing a math problem, you are proving a rate of change to show that cause and effect. On a velocity time graph, that slope is your acceleration vector. If you find the area under a line, you're uncovering an accumulated physical quantity to explain the underlying physics, like total displacement. And when you identify direction, maybe seeing the line dip below the x-axis, you are establishing vector orientation to make a precise physical observation. The object has reversed direction. Every single feature on a graph is a vital, screaming clue to the physical reality of the system. If you just read the numbers off the axis, you're playing Sam's game. If you extract the core trend and explain the physics behind the slope and the area, you are playing the examiner's game. And that is how you win. Stop scrolling. Subscribe to our YouTube channel, Ace the Exams, and AceTheExams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2-3 grade boundaries. Join them right now by subscribing to @AceTheExams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions. All right, let's get back into the arena. This brilliantly illustrates why we bother learning this at all. This micro-topic stretches far outside the four walls of your classroom. Think about transport and safety engineering. This is a massive area for Cambridge application questions. When real-world engineers design crumple zones on the front of your car to crush exactly like soda cans on impact, or when they calculate the precise safe banking angle of a curved highway so cars don't fly off in the rain, they are using vector fundamentals. They are using direction, magnitude, momentum, and impulse vectors to literally prevent real-world disasters. Whether it's energy systems, medical technology, or astronomy, depending on the specific syllabus you are taking, like 5054 or 0652, you should always be able to name at least one real situation where the concept matters. Understanding why the physics helps us improve outcomes isn't just nice to know. It is exactly what secures those top-tier application marks when you face a challenging 6-mark question. But beware, because this Coliseum is full of traps. Let's talk about the common examiner hazards that catch unprepared students off guard. This is our Find the Flaw segment. I want you to think about a flawed sample paragraph. Someone writes, F equals ma, so the car speeds up. What's the flaw there? It hits all 3 of the weaknesses that cause you to bleed crucial marks. Trap number 1, writing a correct formula, like F equals ma, but failing to explain that F is the resultant force in the context of the specific question. A formula is a tool, guys. It is not an answer. Trap number 2, quoting a physics process perfectly from memory, but completely failing to link it to the specific physical effect happening in the prompt. If the question is about a falling parachutist, don't just talk about gravity in a vacuum. Talk about air resistance vectors opposing the weight vector. And trap number 3, giving a real-world example but not showing why it follows from the physics principles you just stated. Examiner reports mention these exact errors thousands of times every single year. You have to actively counter them by being relentlessly specific. So, the crucial point is how we build an absolute unbreakable defense against those traps. Enter the safest exam method. It relies on 4 pillars: definition, relationship, explanation, and application. We call it DRE, and it works perfectly alongside the Peel framework we discussed earlier. Whenever you face a structured question about vectors, you immediately lock into this sequence. First, provide the core definition to secure that first mark. Second, state the mathematical or physical relationship. Third, deliver the explanation, that vital, unbreakable cause and effect chain. And finally, anchor it with the specific application from the question prompt. Now, to make this work, you also need a time management matrix. You should be spending roughly 1 minute per mark. If it's a 4-mark question, you spend 4 minutes building your DRE structure. No more, no less. If you rigorously apply this structure and strictly manage your time, you leave the examiner absolutely 0 room to deduct marks. It keeps every single point tightly connected to both your classroom reasoning and the strict, unforgiving exam structure. To make sure you're truly battle-ready for exam day, I want you to integrate these quick recall revision prompts into your daily study routine. We are going to do a mental speed writing challenge right now. When you review vectors, ask yourself these 4 questions out loud. What is the core idea? What actually changes physically in the system? What specific quantity or graph would show this change? And where is this used in reality? I challenge you right now, pause this explainer or take a screenshot and read these aloud. Speak your answers. Imagine you have a 30-second timer counting down on your screen. Can you write one perfect Peel paragraph answering these prompts? If you can confidently answer these 4 prompts without looking at your notes, your conceptual foundation is absolutely secure. This is the ultimate test of concept first teaching. It forces you to move away from passive highlighting and forces you into active, aggressive recall. That is how champions are made. So, we've covered the strategy, we've looked at the real-world stakes, we've diagnosed the traps, and we've handed you the ultimate framework. Now, here is your final provocative challenge, formatted exactly like a past paper prompt. Explain the physics behind vector fundamentals using a clear cause and effect chain. Look at that prompt and ask yourself, can you survive the test? Do you have the definitions, the relationships, and the precise vocabulary ready to deploy? Don't just memorize the textbook. Understand the structure of the physics itself. Students who implement these physics strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel, Acing the Exams at acingtheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to at acingtheexams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for physics and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Take this strategy, apply it to your syllabus, and conquer the arena. Ace the exams. Your Cambridge success starts here.